Volcanoes are among the most captivating and powerful natural phenomena on Earth, embodying both the raw force of nature and the intricate processes that shape our planet. Formed by the movement of tectonic plates and the subsequent release of molten rock, or magma, these geological structures can vary widely in size, shape, and activity. From the majestic stratovolcanoes of the Andes to the shield volcanoes of Hawaii, each volcano tells a unique story about the Earth's inner workings and the dynamic forces at play beneath the surface. Understanding volcanoes is not only essential for geological science, but also for assessing the risks they pose to human life, infrastructure, and natural ecosystems. The study of volcanic activity has evolved significantly over the years, with advances in monitoring techniques and predictive models enhancing our ability to forecast eruptions and mitigate their impacts. This video aims to explore fascinating facts about volcanoes, including their formation, types, and the effects they have on the environment and human civilization. By delving into these aspects, we can appreciate the complexity and beauty of these formidable geological entities while remaining mindful of the potential hazards they present. The explosive potential of a volcano is determined by several factors, including the composition of its magma and the amount of gas it contains. When magma rises to the surface, the pressure decreases, allowing dissolved gases to expand rapidly. This sudden release of gas can create immense pressure within the volcano, leading to violent eruptions. You may envision a scenario where the magma becomes so thick and viscous, typical of rhyolitic lava, that it traps gas bubbles, intensifying the pressure until the eruption occurs. Such eruptions can send ash plumes soaring high into the atmosphere and unleash pyroclastic flows that devastate the surrounding landscape. Your understanding of volcanic eruptions is enriched by recognizing the varying degrees of explosiveness among different types of eruptions. For instance, stratovolcanoes, with their steep profiles, often produce highly explosive eruptions, while shield volcanoes typically have more effusive, lava fountain-style eruptions. This variation is crucial in determining the level of risk associated with different volcanoes. As you explore this topic, consider the broader implications of volcanic eruptions not only on the immediate environment but also on climate patterns and human safety. Lava flows exhibit a remarkable range of speeds influenced by several factors, including their composition, temperature, and the terrain they traverse. For instance, basaltic lava, which is thinner and less viscous, can travel at speeds of up to 30 kilometers per hour, about 18 miles per hour, when it first erupts. In contrast, more viscous lava types, such as andesitic or rhyolitic lava, tend to move much more slowly, often creeping along at just a few centimeters per hour. The terrain also plays a crucial role. Slopes can accelerate flows, while flat or rugged landscapes may impede their movement. As you consider the behavior of lava flows, keep in mind that their speed can change over time. Initially, when lava is hot and fluid, it can advance rapidly, but as it cools and thickens, its movement slows significantly. This variation can lead to unpredictable hazards for nearby communities, as a fast-moving flow may threaten populated areas, while slower flows can provide more time for evacuation. Understanding these dynamics is essential for assessing volcanic risk and implementing appropriate safety measures. When volcanic eruptions occur, the release of ash clouds can pose significant challenges to air travel. These clouds can extend thousands of feet into the atmosphere, creating hazardous conditions for aircraft. The fine particles of volcanic ash can be particularly damaging, as they have the potential to interfere with jet engines, causing them to stall or fail altogether. Even if an aircraft avoids direct contact with a dense ash cloud, the residual particles can still result in maintenance issues and costly repairs, leading to flight delays and cancellations. In addition to the mechanical risks posed by ash clouds, visibility can be severely reduced, complicating navigation for pilots. Airlines may be forced to reroute flights or ground them altogether in the interest of safety, affecting not only travelers but also the broader logistics of air transportation. Airports in the affected regions often experience significant disruptions, leading to a ripple effect on global travel networks. Understanding the implications of ash clouds on aviation highlights the essential need for monitoring volcanic activity and implementing appropriate response strategies to mitigate these risks. When you consider the formation of mountain ranges, it's fascinating to note how many of these majestic structures are the result of volcanic activity over millions of years. As magma from beneath the Earth's crust escapes to the surface, it can build up and solidify, leading to the creation of various types of volcanic mountains, such as stratovolcanoes and shield volcanoes. These formations can be found in chains or clusters, often resulting from tectonic plate movements that force magma out in specific locations. The result is a stunning landscape of peaks and valleys, shaped not only by volcanic eruptions but also by the forces of erosion and weathering. As these volcanic mountains grow, they can significantly influence the surrounding environment, altering climate patterns and ecosystems. The presence of high peaks can create rain shadows, affecting local vegetation and wildlife. Additionally, the geothermal activity associated with these volcanoes can lead to the formation of hot springs and geysers, adding to the unique characteristics of the region. This interplay between geological processes and natural beauty makes volcanic mountain ranges not only significant in terms of Earth's geology but also vital in understanding ecological dynamics and the effects of climate change. The emergence of hot springs in the area. When magma heats underground water, it creates a unique geological feature where mineral-rich water bubbles up to the surface. This phenomenon occurs in regions with active volcanic systems where the heat from the Earth's interior interacts with underground aquifers. The result is often a collection of hot springs that not only provide a relaxing natural bathing experience but also serve as indicators of the underlying volcanic activity. You may find that these hot springs vary in temperature and mineral content, influenced by the specific geology of the surrounding area. Some springs are known for high mineral concentrations, which can be beneficial for health and wellness, attracting both tourists and those seeking therapeutic benefits. The vibrant ecosystems that often develop around these hot springs showcase the interplay between volcanic activity and life, as unique flora and fauna thrive in the warm, nutrient-rich waters. These natural wonders highlight the dynamic relationship between the Earth's geological forces and the surface world, offering insight into the ongoing processes that shape the planet. During eruptions, gases such as water vapor, carbon dioxide, sulfur dioxide, and various other volatile compounds are released from a volcano's magma. These gases can escape individually or as part of a larger volcanic plume, contributing to the distinct characteristics of an eruption. As you observe the dramatic explosion of ash and molten rock, keep in mind that nearly 90% of the volatile emissions from a volcano are water vapor. This release can significantly impact the surrounding atmosphere and climate, as well as affect air quality and visibility. In addition to their immediate effects, volcanic gases play a critical role in the Earth's geological processes. They can lead to the formation of acid rain when sulfur dioxide and water vapor combine in the atmosphere. Over time, the accumulation of volcanic gases can also influence the Earth's climate, contributing to phenomena like global temperature changes and altering weather patterns. Understanding these emissions allows scientists to better predict volcanic activity and assess potential hazards associated with eruptions. Many of the world's most active volcanoes are submerged beneath the ocean's surface, forming what are known as submarine volcanoes. These underwater giants are often located along tectonic plate boundaries, where the Earth's crust is thin and susceptible to melting. When these volcanoes erupt, they can create massive plumes of ash and gas that disperse in the water, contributing to the formation of new land, such as volcanic islands, over extended periods. The interaction between lava and seawater can also lead to unique geological formations and mineral deposits. Beneath the waves, hydrothermal vents often accompany these underwater eruptions, releasing superheated water rich in minerals. These vents support unique ecosystems that thrive in extreme conditions, providing a habitat for various organisms that rely on chemosynthesis rather than photosynthesis. Thus, the underwater volcanic activity not only shapes the geological landscape but also plays a crucial role in sustaining life in some of the most inhospitable environments on Earth. You might find it fascinating that the Ring of Fire, a horseshoe-shaped zone encircling the Pacific Ocean, is home to over 75% of the world's active and dormant volcanoes. This extensive region is a result of tectonic plate movements, with numerous plates subducting and colliding, leading to frequent seismic activity. Here, you can witness some of the most powerful volcanic eruptions in history, as well as the continuous formation of new land masses. As you explore this region, consider the impact that these volcanoes have on local communities and ecosystems. Nearby populations often adapt their lifestyles in response to the volcanic activity, with some relying on the fertile soils produced by volcanic ash for agriculture. Additionally, the geothermal energy generated by these volcanoes is harnessed in various parts of the world, showcasing the duality of their destructive and constructive capabilities. Knowing this, you gain a deeper appreciation for the dynamic processes that shape our planet and the intricate relationships between geological phenomena and human life. Throughout history, the threat posed by volcanic eruptions has shaped the beliefs and practices of various cultures. You might notice how civilizations situated near active volcanoes often developed myths and rituals aimed at appeasing the gods they believed controlled these powerful natural events. In these societies, eruptions were seen not just as geological phenomena, but as divine warnings or punishments, leading to sacrifices and offerings intended to mitigate the wrath of the volcanic gods. The catastrophic eruptions, such as those of Mount Vesuvius, left lasting scars on the landscape and the consciousness of those who lived in their shadow, forever altering the course of their history. As you reflect on these ancient fears, consider the ways in which they influenced governance, urban planning, and societal structures. Leaders often prioritized the welfare of their people by relocating settlements or establishing warning systems to prepare for potential eruptions. In doing so, they underscored the unpredictable nature of these geological giants and the respect they commanded. This interplay of fear and reverence not only highlights the power of nature but also reveals how human societies have historically navigated the challenges posed by their environment. The unique qualities of volcanic soil significantly contribute to agricultural productivity, transforming regions with volcanic activity into some of the most fertile lands on Earth. This soil, often referred to as Andy soil, contains a wealth of minerals and nutrients that are essential for plant growth, resulting from the breakdown of volcanic rock and the accumulation of organic matter. As you explore areas enriched by volcanic soil, you'll notice lush vegetation and vibrant crops thriving in the nutrient-dense environment, making these regions ideal for farming. Moreover, the high porosity of volcanic soil allows for excellent drainage while retaining moisture effectively, creating an optimal growing condition for various agricultural products. This balance of drainage and moisture retention not only supports diverse ecosystems but also allows farmers to cultivate crops with minimal reliance on artificial fertilizers. Consequently, communities living in volcanic regions often experience agricultural abundance, showcasing the dual nature of volcanoes as both destructive forces and providers of rich, fertile land. In conclusion, remember that volcanoes, while often associated with destruction and chaos, also play a fundamental role in shaping our planet. Their formation, eruption cycles, and the unique ecosystems they create can be both fascinating and calming to contemplate. By understanding the science behind these natural wonders, you not only gain knowledge but also a sense of connection to the Earth itself.